Sitting alone in the eastern Pacific, Rapa Nui is separated by thousands of miles of open ocean from the nearest continent. The early Polynesian navigators who settled here were geographically bound to this single patch of land. For decades, the story of this island has been told as a grim warning. The popular narrative claims the inhabitants became obsessed with carving their massive stone statues, ultimately chopping down every tree on the island and triggering an ecological suicide. When 18th century European explorers arrived, they found a largely treeless landscape. Looking at the monumental architecture, they assumed the indigenous people had exhausted a lush environment to fuel their own construction projects. The modern version of this theory argued that the island once held up to 15,000 people. According to this framework, that massive population rapidly stripped the soil bare, leading to widespread starvation, warfare, and a demographic crash well before Europeans ever arrived. Data from satellite imagery and ancient DNA reveals a different reality. The biological and physical evidence shows that this presumed demographic collapse never actually happened. To understand the island's history, you have to look closely at the dirt. Rapa Nui's volcanoes have been extinct for 1 million years, giving centuries of heavy rain plenty of time to leach away the potassium, phosphorus, and nitrogen required for plant growth. Beyond the dead soil, the island's topography offers very little protection. High salinity ocean winds constantly batter the exposed landmass, accelerating the erosion of whatever fragile topsoil remains. The early settlers initially practiced traditional slash-and-burn farming. As the native palm trees were cleared over time, the soil lost its last natural barrier against the wind and salt. The loss of the island's forest created a severe environmental constraint. Instead of starving, the Rapa Nui responded to this limitation by developing a specialized agricultural strategy to keep their crops alive. They abandoned traditional open-field farming and engineered a system known as lithic mulching or rock gardening. The process demanded intense physical labor. Islanders broke up the exposed bedrock by hand, layering fist-sized stones over the topsoil, building boulder walls against the wind, and churning rock into the ground. This cross-section reveals the system's chemical mechanics. Weathering rocks continuously released essential mineral nutrients into the dirt, feeding sweet potato roots. The stone layer also absorbed daytime heat to stabilize temperatures and trapped ground moisture that would otherwise evaporate. The Rapa Nui recognized the exact chemical deficits of their environment and engineered a precise, labor-intensive method to extract food from a barren landscape. In the past, researchers estimating the island's carrying capacity often misidentified natural geological deposits as these ancient rock gardens. Today, analysts use shortwave infrared, or SWIR, satellite imaging to filter out the natural rock. SWIR sensors detect specific variations in soil moisture and mineral composition. This allows machine learning algorithms to map the precise boundaries of human-engineered lithic mulch. The SWIR data reveals the actual footprint of the island's rock gardens was exactly 0.76 square kilometers, roughly 180 acres. Calculating the maximum crop yield of these plots and factoring in marine protein sets the absolute limit for the island's population at approximately 3,900 individuals. Because the island never possessed the agricultural capacity to feed 15,000 people, the mathematical conditions for an ecological demographic collapse were never met. The physical record is supported by the biological data. In September 2024, an international research team successfully sequenced the whole genomes of 15 ancient Rapa Nui individuals who lived between 1670 and 1950. Geneticists analyze these samples to measure runs of homozygosity. This metric detects close kin inbreeding, which reliably spikes whenever a population experiences a sudden bottleneck or crash. As this chart illustrates, the expected genetic spike never occurs. Instead, the inbreeding coefficients for the ancient Rapa Nui remained exceptionally low, proving the community maintained a stable breeding pool through the 17th century. Further biological kinship analysis identified no first or second-degree relatives among the sequenced individuals. Despite their extreme physical isolation, the islanders successfully managed their social dynamics to prevent close endogamy. The DNA perfectly aligns with the satellite mapping. The Rapa Nui maintained a resilient, genetically diverse society for over half a millennium, adapting to their environment without suffering a pre-contact collapse. A demographic collapse did eventually occur on Rapa Nui, but it was driven by external historical shocks in the 1860s, more than a century after European contact. Peruvian slave raids forcibly removed roughly a third of the island's population. The few survivors who were eventually repatriated brought a smallpox epidemic back to the island, devastating the remaining community until only about 110 people were left. The monumental statues they left behind were the result of highly cooperative, decentralized labor networks, carefully managing the resources they had. The archaeological and genetic record demonstrates how a small, isolated community utilized specialized engineering to thrive within the limits of a restrictive landscape. Sitting thousands of miles from the nearest continent, Rapa Nui is one of the most geographically isolated inhabited places on Earth. Its volcanic terrain is rugged, and its natural resources are severely limited. Yet ringing the perimeter of this marginal landscape are hundreds of massive stone statues, some weighing up to 75 tons. These figures stand upon ahu, megalithic platforms built from precisely fitted dressed stone. The largest of these ceremonial structures reach 5.5 meters in height and stretch over 100 meters along the coast. For centuries, outsiders faced a mechanical paradox. Moving blocks of this magnitude across rough volcanic slopes seemed impossible for a society lacking draft animals, wheels, or the abundant timber needed to create wooden rollers. Early European observers and many later researchers assumed that achieving this required a top-down, coercive empire. The prevailing theory argued that a centralized dictatorship strip-mined the island's forests to roll the statues and exhausted its population through forced labor. Understanding the actual transportation method requires an analysis of the physical dimensions of the stone. The specific measurements and shapes of the statues provide a direct record of the mechanics used to move them. Along the ancient dirt paths radiating outward from the primary volcanic quarry, dozens of statues sit perfectly upright. For decades, archaeologists assumed these were simply abandoned in transit. This 3D profile reveals a highly specific structural morphology. Unlike the flat-bottomed statues erected on the coastal platforms, these road models possess wide, D-shaped beveled bases. Their center of gravity is pitched forward at exactly 14 degrees. Notice the blank faces. The carvers intentionally left the deep eye sockets uncarved during the transport phase. Leaving that extra stone intact kept the head exceptionally heavy, maintaining that aggressive forward tilt. This geometry was designed for kinetic motion. It forms the physical basis of the walking Moai hypothesis, a method where a small team could move the massive stone upright using 3 sturdy ropes. This vector graphic shows how the physics work. 2 lateral teams pull rhythmically from side to side, generating a rocking motion. A third team at the rear holds tension to keep the forward-leaning statue from falling. Because the base is curved like a D, that left-to-right rocking translates into forward momentum. The statue effectively wobbles ahead on its front corners, utilizing its own immense mass to take steps. The island's infrastructure was custom-built to support this. The ancient transport pathways measure 4.5 meters wide and feature a concave, inward-curving cross-section. This shape acted as a stabilizing track to keep the heavy base centered as it rocked. When researchers built a 4.35-ton replica with this exact forward-leaning design, they put the theory to a physical test. A modern team of only 18 unskilled people successfully walked the replica 100 meters in just 40 minutes. Moving the Moai relied on an application of center-of-mass engineering that became more stable as the statues increased in scale. This allowed for the transport of massive stones without the need for large timber supplies or draft animals. The geometry of these stones also clarifies Rapa Nui's social structure. Independent analysis of the island's sculptural inventory reveals a stark division between the statues by the coast and those left inland. Statues standing at the quarries and along the roads are on average significantly larger than the ones erected on the coastal ahu platforms. Additionally, the inland statues have relatively thinner bases compared to their overall height. If the Rhodes statues were simply unfinished coastal deliveries, they should share the exact same proportions. This inverse sizing indicates these massive figures were deliberately carved to remain permanently beside the roads and quarries as localized markers of power. To map how these local groups operated, researchers deployed UAV photogrammetry to compile nearly 12,000 high-resolution images of Rano Raraku, the primary volcanic quarry. When assembled into a three-dimensional model, the quarry resolved into 30 distinct, spatially separated workshops operating across the volcano. Each of these 30 zones displayed unique carving techniques. Furthermore, each workshop maintained its own independent transport path, routing its finished statues in completely different directions out of the crater. There was no single production line and no central authority managing the labor. The landscape reflects a highly decentralized society, where independent, autonomous kinship groups worked cooperatively side by side. This capacity for independent engineering extended into intellectual design. Rapa Nui is home to Rongo Rongo, a complex glyphic script carved into wooden tablets. One artifact, known as Tablet D or the Échancré, presents a unique geographical puzzle. Botanical analysis confirmed the tablet is made from African yellowwood, a species of conifer native to southeastern Africa that cannot grow on Rapa Nui. This map traces how the wood likely arrived. It floated across the ocean as marine driftwood, carried thousands of miles along southern currents before eventually washing ashore on the island. Because of the old wood problem in archaeology, radiocarbon dating can only tell us when the tree's outer rings stopped growing and absorbing carbon, not the specific year a scribe carved the text into the wood. However, the wood securely dates to between 1493 and 1509 CE. Given how quickly driftwood decays in the elements, its pristine preservation indicates the islanders collected, carved, and protected it well before European contact. The text itself features highly standardized structural patterns. Researchers recently identified recurring delimiter sequences that form a second lunar calendar, demonstrating a systematic method for recording astronomical data. Linguistic analysis shows the phonetic and semantic rules of Rongorongo are rooted entirely in the East Polynesian language branch. The structural integration of local language into this script strongly supports Rongorongo as a pristine, independent invention of writing. Even today, ongoing modern climatic shifts continue to expose exciting new layers of data from Rapa Nui's ancient landscape. In February 2023, a severe drought caused the crater lake inside the Rano Raraku volcano to dry up entirely. Buried in the exposed lakebed, archaeologists found a previously unknown 1.6-meter moai. This statue features a flat, squared base designed for standing flat, and its eye sockets are fully carved out. Because carving the eyes was the final step of production, the statue was fully finished. It was intentionally erected in the center of the wetlands, likely functioning as a physical water level indicator or a ritual boundary marker for a vital freshwater seep. This clearly demonstrates a highly targeted use of monumental architecture to manage scarce hydrologic resources. The islanders were not blindly exhausting their environment on megalithic vanity projects. Rapa Nui's record shows a society of structural engineers, independent inventors, and autonomous collaborators. Their cooperation within a marginal environment allowed them to achieve the extraordinary.